Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well. And yeah, you're ready for today's program. Because today on the show, we have, of course, Ralph Bond. He is our science and tech trends correspondent. And he'll be joining us here in just a moment to talk all things, well, science and technology. Ladies and gentlemen, it's always a fun segment. And if you want to find out more, computeramerica.com. That's where you'll find us. You'll find everything from the show notes, past shows, future shows, videos, archives, articles, reviews, anything and everything that Computer America does, you can find it there, including the ever-changing social media landscape. Because man, I don't know. We've been talking about the whole Twitter rebranding thing all week, and I don't know. Elon Musk proves time and time again. I don't know what genius is, apparently. So we'll find out. But ladies and gentlemen, with that being said, computeramerica.com, that's all you need to remember. Of course, we'll have a link to Ralph's website. And of course, we have a segment at the top of the page that is dedicated wholly to Ralph. So if you want to find more of his segments, we have a playlist, we have past show notes, and it's super simple. So with that being said, I hope that you're doing happy, you're healthy, you're nice and cool. And with that being said, let's go ahead and bring Ralph on. So of course, he's been a longtime contributor to Computer America. You may remember him a long ago as Intel's Digital Minute voice, but of course he has come to really highlight that technology is changing not just the cell phone in your pocket or the computer that you are probably listening to us on, but actually it changes everything around us. And he has a great segment dedicated to these changes and, dare I say, these trends. So Ralph, welcome back onto the program. How you doing?
I'm doing great. And again, folks, what we do every Friday is share with you where things are headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. Everything is eligible for Ben and me to take a look at in terms of trends. So that's why I'm the science and technology trends correspondent for the show. And again, as Ben mentioned, come out to computeramerica.com. Be sure to get the show notes if you want to dig deeper, because what we're going to do is highlight 4 stories and give you the essential points. And then if you want to go deeper, come out and get those show notes. And we've got some great stuff for today.
Absolutely. 4 and then some. I saw that you have a couple honorable mentions there at the end of the segment. So, yeah, but before we get to those, of course, we can tap into, I'm sorry, I read ahead a little bit. We should go ahead and do story number 1. And algae is not the first time that it's come up on the show, but it's amazing what such a simple thing can do in so many fields.
Yes, I love this story because, selfishly speaking, it's very Northwest United States based. Folks, I'm based outside of Portland, Oregon. And here's the headline. Researchers at the Pacific Northwest National Laboratory are exploring how to use algae to tap into the vast reserve of mineralogical wealth in the oceans. What? Okay. This comes from their own website and a story by Steve Ashby. It's great. This is fun. Okay, so here's the deal. Critical minerals and rare earth elements are used in technologies such as smartphones, LED lighting, wind turbines, X-ray machines, and catalytic converters. I think we all know that. There's the reliance on critical minerals. Now, today, many of these essential natural resources are mined predominantly in China. And that, in the world we're evolving into could be a problem, perhaps. Researchers at the Department of Energy's Pacific Northwest National Laboratory up in Washington State, by the way, are exploring alternative sources of these minerals that are less vulnerable to supply chain disruptions. So that's the key. In this quest, the laboratory researchers are looking at the oceans as an under-tapped resource for minerals typically dug from the ground. And I love this factoid from this story. This just made me stop and gasp. A spoonful of seawater contains not just salt, but every element in the periodic table. Wow. Even though they are found in low concentrations, only parts per trillion, I mean, that's small, oceans are perhaps the largest single source of rare earth elements on the planet. Wow. And in the show notes, I have a side note about the periodic table. If you want to get a spin up on that, we're not going to spend time going through that, but I even have a reproduction of the table itself. It's probably saw it in your high school science class or college or what have you, but it's there if you want to learn about that and get more spun up on that.
Right.
Back to the story.
And of course, for everyone out there that can, of course, see, and, those who can picture in their mind, that section at the bottom that's, kind of taken out and dropped below the rest of the table, those are the rare earth metals. So those are the elements that we're talking about. So the kind of the green background one at the bottom. That's cool. I since I've been in the ocean growing up, I always just assumed it was Florida and the way that their water tastes. But no, it turns out it's every element known to man in the water. Who knew? I thought it was just Florida.
A smoothie of elements.
Yes.
Sort of. Anyway, back to the story. Moreover, because the oceans are not controlled by any one nation, well, that's a little bit arguable these days. Anyway, they avoid many of the geo-economic political issues we read about in the news. Now, in one promising project, Pacific Northwest National Laboratory researchers are investigating how algae can be used to harvest certain critical minerals from seawater. Rather than chemically or physically separating these minerals, researchers are exploiting biological processes that concentrate them so they can be cost effectively produced. Isn't that fun? So they're saying, can nature do this for us instead of us trying to create amazing machines? Answer, potentially, yes. To better understand these processes, the laboratory team are utilizing the unique capabilities of their Marine and Coastal Research Laboratory located on Washington State's Olympic Peninsula. With direct access to flowing seawater, they are growing different species of algae in the laboratory. And some of the algae are green, others are red, some are leafy, others are stringy. And looking closely at each, researchers are gaining insights into their properties and tendency for extracting different minerals from the seawater. And they're finding some algae can concentrate certain minerals 1 million times more than found naturally in the seawater. So they can jack up the extraction by 1 million times. Isn't that something? Wow. Results also show the process improves ocean health. So this is like a win-win scenario. Extract minerals we need and improve the ocean health. Wow, gotta love that. Water flowing out of the algae tanks is less acidic because the carbon stays in the algae, as do the nitrogen and phosphorus, helping to prevent possible harmful algae blooms. Wow, I just love this story.
Like, I'm guessing physically or chemically trying to extract these things. I mean, parts per trillion, I'm not the best at it. Like, Ralph, things are usually measured in like parts per million in the air and parts per billion in drinking water and stuff like that. Parts per trillion sounds super minute. So I guess that when the algae grows, then kind of chemically make it so that it pulls these elements out and it grows into, or at least, the algae sucks it into their system. I'm guessing they just like release it, or they have like these big floating, I guess, algae tanks that they can, kind of put in the ocean and just constantly like let the tides refresh the water and just let them grow and do that kind of thing. I mean, very, very interesting concept. I'm curious how they're going to kind of do it at scale, because even parts per trillion and then even millions more times within the algae. Very curious how big this can scale, but like you said, though, win-win. It has a lot of benefits, a lot of upside.
Well, yeah, and Ben, you make a good point. I too also thought to myself, well, is this research for the sake of research, or is it research on a path to real world application? And my experience with the Pacific Northwest National Laboratory stories that we've done occasionally, and I follow them closely, they're kind of like the MIT of the Northwest. Okay, they have their
very experimental.
Very experimental, but all over the map. But like MIT, usually, with very rare exceptions, a path to possible practical real world application and benefits. So we'll see. I'm with you. You would have to have, I would presume you'd have to have this implemented at such a gargantuan scale to harvest the kind of minerals that would be meaningful as an alternative to that, which we're digging out of the ground in China. But it's also very passive.
So, kind of.
Yeah, that's true. Yeah.
Maybe. So we'll definitely see. Story number 1, story number 2. And speaking of passive, it seems to be everyone's favorite thing. When you have something and it does something by itself and you just get to reap the benefits. Well, story number 2 is a great example of that. Although, like you said in the title, very science fiction-esque, but please.
Yes. All you have to do is think about the Terminator movies, right? Mm-hmm. where the robot gets shot in the face and all of a sudden it just kind of wiggles a little bit and the face comes right back. Right? Okay. Well, the headline here is self-healing metal, ? It's not just the stuff of science fiction. Got this from the Reuters news service. This was also covered by many, many other news services. A story by Will Dunham. And we've got the link in the show notes for you and an image as well. So here's the deal. On July 19, very recently, right? July 19, scientists at the U.S. government's Sandia National Laboratories in New Mexico described how pieces of pure platinum and copper spontaneously healed cracks caused by metal fatigue during nanoscale experiments that had been designed to study how such cracks form and spread in metal placed under stress. They expressed optimism that this ability can be engineered into metals to create, self-healing machines and structures in the relatively near future. Wow.
Is that what all the Senate hearing committee was on alien technology? It was just copper and metal plate, healing.
There you go. Yeah, there you go. Let's do a conspiracy. We'll make up our own. This is really coming from aliens. It's not the laboratory. They're just taking alien technology.
They're trying to piecemeal the alien technology out, and Sandia just won the lottery. Yeah, that's it.
Well, speaking of that sort of stuff, we'll segue just for a moment. I saw in the news services, this got a lot of popular pickup, but I don't know how valid it is. But there's images from Mars that appear to show some things in the dirt, if you will, that don't look natural. There's like these kind of bow-like shapes with spiky-like little projections that look too regulated to whatever to be naturally formed. Now, nobody knows for sure, and I don't know how valid all this sort of stuff is. But if you Google,
is it kind of these weird rock formations?
It's much more mechanical looking than that. I wish I had a link for you.
Well, but that's probably the rover that you're seeing. No.
Right. Yeah. No, it's maybe if you Google recently discovered what appear to be man-made items on the surface of Mars, maybe it'll come up with the images I'm referring to. It looks like these might all be credible, and it might have been incredible resources or references that were citing this stuff, because I'm not seeing what I saw. I'll send you the link later.
Yeah, sure. Mars is always full of images that are like, is that a stone face of Mars and stuff like that.
Right.
Definitely full of that stuff. But no, we're back on Earth and we're talking about metals that are actually doing things.
Yeah, self-healing metals. Back to the story. Okay, so a little more background here. Metal fatigue occurs when metal, including parts and machines, vehicles, and structures, sustains microscopic cracks after being exposed to repeated stress or motion, damage that tends to worsen over time. And by the way, metal fatigue can be a long-term process. We know this from our steel bridges and so forth. Here up in the Northwest, for example, they're going to replace a bridge that links Oregon to Washington State across the Columbia River because in part of long-term metal fatigue. So it can happen over a long period of time. Metal fatigue can cause catastrophic failures in areas including aviation, jet engines, for instance, and infrastructure, bridges, and other structures. So that's the problem. But in the experiments at the Sandia National Laboratories, researchers used a technique that pulled on the ends of tiny metal pieces about 200 times per second. Oh my gosh. That's fast. 200 times per second. A crack initially formed and spread, but about 40 minutes into the experiment, the metal fused back together. We need the Twilight Zone music track for a second there. Anyway, isn't that something? The researchers called this healing, they observed, cold as in cold temperature, cold welding. Huh.
Well, I don't think I have that, but I do have.
Yeah, we'll go with that.
I do have the X-Files.
That's weird enough.
but no, so essentially 200. It's not X-Files. So they pulled it 200 times per second, and to I guess kind of create those little micro cracks that would take normally years to kind of create. To tie it to another relevant story not too long ago, although everyone's moved on, which is good. The submarine that famously imploded. People were thinking that, we did the first 13, 14 dives relatively well, and then just the 15th, those little micro cracks that they didn't inspect or they didn't see caused the whole thing to implode. So, micro cracks, I guess, affect a lot of different fields.
Well, yeah, and that, of course, was a terrible tragedy. But going back to this cold welding phenomenon, according to research scientist Brad Boyce, who helped lead the study and published the results in a journal called Nature, quote, "The cold welding process is a metallurgical process that is known to occur when two relatively smooth and clean surfaces of metal are brought together to reform atomic bonds." Bonds, not bombs, but by the way, folks, BONDS. I know I've got that Oppenheimer movie on the mind lately.
Yes.
And Boyce further noted, quote, "Unlike the self-healing robots in the Terminator movie, this process is not visible at the human scale, or to our eyes, of course. It occurs at the nanoscale, and we have yet to be able to control the process." So they've observed it, but they have yet to figure out how can we consciously and manipulate this process. And remember, of course, nanoscale means a size measurable in nanometers or microns, and a nanometer is 1/billionth with a B of a meter, folks. We're talking tiny. Now, metal pieces that they tested were about 40 nanometers thick and a few micrometers wide. While the healing was observed in the experiments only in platinum and copper, Boyce said simulations indicated that self-healing can occur in other metals, and that it's entirely plausible that alloys like steel could exhibit this quality. So they're optimistic they can apply this, and if they can learn how to control it and deal with it, they may be able to apply it to things that we use every day in life, like steel. Given this new knowledge, there may be alternative material design strategies or engineering approaches that could be devised to help mitigate fatigue failure in metal. In addition, this new understanding may shed light on fatigue failure in existing structures, improving the ability to interpret and predict such failures. Now, in the article, Ben, they did stand back and offered some what I like to call reality checks. So First of all, the self-healing of this metal was observed in a very specific environment using a device called an electron microscope. That's one thing. The researchers noted that tangible applications of their findings, they predict, will take about another 10 years to develop. So this is a twinkling of the eye, talk about early trend observation kind of story. So we'll see. It
really is one of those processes that even if they can't turn it into something that is really, as we would consider it, useful, knowing that it happens and knowing how it works is always an important part to building and manufacturing these things. You can't just have this big question mark area that's like, cold welding process, how does that work? It's like, it doesn't matter, just build it anyways. Knowing how it works has implications as well, even if you can't control it. So very cool. And of course, the tiny pictures, I'm guessing that this the picture you have in the show notes, which you can get at computeramerica.com, I'm guessing this green part right there is kind of the part that welded itself back together. So very, very
Isn't
cool.
that something? It's very odd, very spooky, weird kind of stuff. I don't know. I certainly don't fully understand it.
Right. No, but even those extreme conditions, it's still a very cool process. So story number 2, story number 3. And I think everyone's very familiar with Wi-Fi at this point. If you don't have it, you know it. But now we're going to talk about something a little bit different. And Li-Fi, I think I've heard of it before, but Ralph, I'll be honest. After going to CES for so many years and covering news and new technology for so many years, acronyms and abbreviations they all just kind of meld together. So tell us, what is Li-Fi?
Yes. Well, this is really fun, and I learned a lot from researching this story. So here's the headline: Trend to watch. That's my insertion. Here's the headline: What is Li-Fi? That's Li-Fi. Li-Fi. Well, a faster, more secure wireless internet is just around the corner. That was the headline. I got this from Digital Trends, a story by Jon Martindale. There's in the show notes, folks, if you're just listening to us on the podcast, please come out to computeramerica.com, get the show notes. There's a great illustration that I picked up from the article. Also, the official logo for Li-Fi, you can see that as well. But here's the deal. Li-Fi has the potential to revolutionize not only the way we get online, but it could even replace some of the mountains of cables that make up the backbone of the modern internet. So, wow, okay, that's pretty profound. But I'm going to insert a little note here because I dug into this, did a little bit of additional research. Li-Fi, what we're talking about here, folks, is not saying, drum roll, please, all of a sudden Li-Fi has never existed and now this week it does. No. Li-Fi was introduced as a technology way back in March of 2011. So the story here is more about it being becoming deployable versus this being a brand new technology. And we'll talk more about this in a moment relative to a recent Institute of Electrical and Electronics Engineers, good old IEEE, their recent amendment to the Wi-Fi specification. This will all make sense in just a moment, so bear with us. So here we go. Li-Fi is short for light fidelity and is a communication system that utilizes light rather than radio waves to transmit data. A Li-Fi network uses infrared LED lamps to transmit and receive data, using modulations in the light intensity to create the digital signal which carries the information to and from various network devices. So there's your 2-second kind of tutorial on what is this Li-Fi stuff.
So instead of using the unseen, wireless signals that we're used to, it's using, essentially light, but even like a lower bandwidth of light that you probably, it's not like your entire house is going to be strobing with data,
No,
it's just,
you're right. No,
it's going to be shining light and the data will go through. Right.
That's right. That's right. And Li-Fi works by try that again. Li-Fi works by utilizing light pulses, which are invisible to the human eye. To your point there, Ben. These pulses are modulated in intensity. Get ready. These pulses are modulated in intensity billions of times per second. What? And it's those modulations that receivers can track and translate into data entirely wirelessly. The part that just absolutely floored me was billions of times per second. I can't even wrap my head around that. That's just wild. So this isn't totally dissimilar to the way Wi-Fi works, what we know today, which of course works with radio waves, except radio waves can more readily pass through and around obstacles. Li-Fi can do that to some extent, but it's more reliant on line of sight, which places a limitation on its range and abilities outside of open plan homes and offices. So that's a reality check.
Yeah, you could really imagine where if you need, that constant light source to, modulate billions of times a second, like you said, the sun is totally going to interfere with that signal. So you can't exactly do it in like a stadium or a football field.
Yeah, you're right, Ben. There's a lot of reality checks we're going to get into a bit about it's not able to penetrate. Like in my house, of course, you have your router and your Wi-Fi router and all that kind of stuff. And I can pick up the signal downstairs. It could go from upstairs to downstairs through the floors. All of that. That's great. This Li-Fi stuff would not be the answer there, but we'll get to where I think it does make sense. So Li-Fi has the potential to be faster than traditional Wi-Fi. That's great, but technically speaking, up to 100 gigabits per second. However,
that's fast.
However, the recently approved amendment to the Wi-Fi specification that adds Li-Fi support, that's a key phrase, adds Li-Fi support, IEEE 802.11bb, Baker, lowercase, 802.11bb. You're going to learn more about this as time goes on. Rates Li-Fi technology with a minimum throughput of 10 megabits per second and a maximum throughput of 9.6 gigabits per second. So that's far below the theoretical possibility of 100 gigabits per second. Okay, that's okay. They're, baby steps. That puts it at about the same range as Wi-Fi 6, the most recent iteration of Wi-Fi network protocol for now. This is all, baby step. Okay, guys, but time out. The big news is that this IEEE certification provides a globally recognized framework for deployment of Li-Fi technology according to Li-Fi tech companies, Pure Li-Fi and Fraunhofer, HHI. And I have links in the show notes for both of these companies. Really interesting stuff. So that's the key here, Ben. It was developed in 2011. It has this huge technical possibility. It has certain limitations. But what happened is the IEEE recent certification of deployment of 802.11bb is the door opener to get this out into the real world.
Right.
That's the point. And so reality check, although a Li-Fi signal can bounce off walls and other objects, it is severely impacted by impediments and obstructions and has a rated maximum range of about 10 meters. That's approximately 33 feet.
Yeah, 10 meters, a pretty good comparison I think that you can make between this is Bluetooth. If you use Bluetooth to any extent,
there you go.
Bluetooth is also rated for 33 feet. So you can, kind of compare that.
Yeah, that's an excellent comparison. So it's hoped that Li-Fi will be used in the home as a secondary connection layer, That's the key. I think the reality is not throw your Wi-Fi out and everything goes Li-Fi. Heavens no. But it could be a really clever companion technology working in harmony with Wi-Fi. So Wi-Fi, Li-Fi, it'll be, a really interesting mix. So this mixing it together is a secondary connection layer, thereby allowing for faster transfer speeds and the ability for more devices to connect to a compatible router at once without connection speeds falling. Li-Fi could also be used in environments where interference is common and data purity is of the utmost importance, like hospitals, schools, and financial institutions. Data centers, too, could see some benefit. Li-Fi could be used to transmit data over short distances where running cables would be prohibitively complicated or costly, and Wi-Fi could be Wi-Fi would be too insecure or prone to interference. So where Wi-Fi might be insecure or prone to interference, maybe Li-Fi could be useful if you have line of sight, right? Now, although it's likely we'll see Li-Fi routers in the future, one idea is to use Li-Fi equipped lighting fixtures in the ceiling of buildings. Ooh. This would allow a data connection through a home's existing power line infrastructure, then utilizing the Li-Fi light fittings to disseminate the data wirelessly to wireless devices. So there's one little light bulb that's a Li-Fi light bulb transceiver, rather.
Right.
Isn't that? Yeah. So that's how it might get deployed. But again, the news, folks, technology from 2011, IEEE gives us the first implementation specification for global distribution. Stand by. Let's see what happens. Again, it doesn't replace Wi-Fi. it could hold hands with Wi-Fi and be a great solution for many situations in business and in your home, etc.
Well, yeah, and I definitely see it the same way that even your Wi-Fi right now, you have Wi-Fi, the 5G, you may see the 5G network versus just the regular Wi-Fi network. The 5G, even though it's faster, it's better in so many ways. It doesn't replace 2.4. They both, happen simultaneously because 2.4 has some benefits that 5G doesn't. And now, Ralph, I think we're up to like 6G or something like that. There's like the 6.4 or something like that gigahertz bandwidth as well that the new routers are coming out with. And looking at the light, I'm kind of curious, Ralph, like in modern design, like, when you're designing like a modern home, those LED strips are everywhere. You put them as accents, you put them behind things, makes everything look all futuristic and cool. I'm curious if, maybe in the future, instead of having to, connect your TV via Wi-Fi and it stutters and it's laggy and stuff like that, those little those accents that fill a home, Ralph, if they become like, if you put them, let's say, behind a TV, backlighting a TV is pretty common nowadays. That would be your data connection. Doesn't matter what TV you put up. It doesn't matter what you do. You put the TV on the wall, you just plug it into a power source, and the light itself would be the data connection. So you don't have to connect it to Wi-Fi or anything like that.
That's a great idea.
Yeah, little applications like that are going to start coming into the home and, hopefully providing some benefit. So we'll see.
Oh, yeah, absolutely. And as the article itself pointed out, the idea that you could have implementations of this where heavy, bulky cables running from here to there would be messy. You'd have to embed them in the wall or what, no, just have these light transmissions to take the place of bulky cables where it makes sense and where you have the distance issues overcome and so on and so forth. And can you have these things in tandem? Yeah, 10 meters, 33 feet, but couldn't you do a tag team incremental, baton passing kind of thing to overcome that distance? So there's all kinds of possibilities.
It's kind of fun because the technology it's not a new technology. I'm not even talking about like 2011. Like this is the same technology that went through copper cables. This is the same technology that goes through fiber optics. Sending a little burst of electrons, little burst of lights, super fast. Ralph, this is essentially fiber cabling without the cable. It's just it's just a little signal.
Great.
So
that's a great comparison.
It's a technology that we know and we know how to use. It's just this one has a bit more interference than fiber optic cables do. So when it comes out, people will see this in their homes when it's finally consumer ready. But not quite there, but we're getting there.
Oh yeah, it's
so
fun.
There you go.
Definitely a trend to watch.
For sure. So story number 3, story number 4. And I don't think a light's going to work for this one, but hey, this one is very cool. And, as is tradition, story number 4 is medical technology.
That's right. Yeah, we love to end the segments usually, almost always, with something in medical technology, because that's just one of my great personal passions and kind of hobbies, if you will, based on my own body experience over all these years. Okay, so here we go. Headline: Spiral brain-computer interface slips into ear canal with no loss of hearing. How could you resist that headline? I've got to know more. What's that? Anyway, it comes from medicalexpress.com, a story by Bob Yirka. This is really interesting stuff. If you've got the show notes, you're watching us online, you can see the image of the little spiral brain-computer interface and more of a graphic images showing it in the human ear and so on and so forth. And there's even a video you can watch as well. So if you're listening to us on a podcast, come out to computeramerica.com, get the show notes. You can see all this we're referring to. However, here we go. A multi-institutional team of engineers in China has developed a new type of brain-computer interface that can be easily slipped in and out of the ear canal. In their project, reported in the journal Nature Communications, the group set out to design and build a new kind of brain-computer interface that is less invasive than existing devices. Is it ever? And I just want to soapbox and segue just for a moment. My heart breaks every day that we have a world where we see people as enemies. How sad. Wouldn't it be great if we could all stop this foolishness of tribal hatred back and forth and suspicion and wanting to take over Taiwan and God knows what, and just stop this and just all work together? Because look what these guys in China are doing. It's just anyway,
there's definitely amazing research happening in every country. Sometimes we talk about Sweden, sometimes we talk about America, sometimes China, sometimes to your point, Singapore, Taiwan, Korea. It doesn't matter. All of these scientists, they really they really build off of each other. And you're absolutely right. Just if there was a way more than just publish a paper and hope that it gets read, but to actually have that community be more closely knit, the research community, absolutely, we would see way more progress.
Well, and this is a good example here. We have researchers in China, and they're publishing this information in Nature Communications in this journal. So they are opening it up to the world, which is commendable. And that's what we need more of. Let's hold hands together with science and technology and stop all this foolishness. Anyway, I digress. Back to the story. So a brain-computer interface, this is a generic kind of definition, is a device that allows communication between the brain and a computer. Though to date, most such devices, brain-computer interfaces, are one-directional. They are used to listen to brain waves for such applications as converting them to text or to electronic signals that can be used to engage another device, such as a wheelchair, right?
Real quick, when you say it's one directional, part of me is like, good. I don't want a brain implant that tells me, what I want for lunch or what I think about Ralph's statement about, don't fight each other. You know what I mean? I'm kind of glad, but no, maybe there's a good benefit to having a two-way communication.
I think the intent is good. The implementation, you can always take technology and pervert it for badness. But anyway, so one of the main drawbacks of most brain-computer interfaces is their invasiveness, referring to what we've had to date. Current approaches involve the use of electrodes attached to the scalp. We've all seen that. Or microneedles or probes that pierce the skull. Yikes. In this new effort, the team in China has built a brain-computer interface that is not only less invasive, but can be engaged and disengaged easily. The new corkscrew-shaped brain-computer interface is called the Spiral E. That's the letter E as in echo. It is engaged by gently screwing it into the ear canal and disengaged by doing the reverse. Couldn't be more simple. It is made mainly of soft material to ensure comfort for the wearer. The design allows the passage of sound waves, ensuring that it does not impair hearing. And the soft material comprising the body of this device also prevents echoing inside the spiral. Wow. The research team suggests that the Spiral E could open the door to new brain-computer interface applications due to its ease of use. They envision the development of applications that convert full thoughts into text, controlling objects in both the real and virtual worlds, and even perhaps augmented memory. Right, augmented memory. That just, talk about leaving you with a boing. What's the possibilities with that? I'd like to have augmented memory, believe me.
Yeah, and no, just remembering what you had for breakfast would be, so amazing. I can't even imagine a future like that. But no, and of course, just wanted to check out the video where sped up 9 times. So it's not like you have like a literal like worm going into your ear or anything like that. It'd be very subtle, and I'm sure that you would feel it. But hey, if you're in a situation where you would need something like this, you probably got things that need tracking or monitoring or things like that. Very, very cool though. And of course the spiral design, I guess with like hearing aids and stuff, it completely blocks and transmits and things like that. So this is very different and very, very cool to see it kind of flex and move on its own. Again, sometimes we cover stories like that, Ralph. It's like this robot, this micro machine, and they don't look like robots like we think of. Again, we don't think of Terminator, but they are technically robots. So very, very cool.
Very cool story. And then, as you mentioned at the outset, a couple of honorable mentions. We're not going to take time with the show to go into this, but get to the show notes and you can see what I'm talking about. So first and foremost, this week, I was absolutely thrilled to watch a wonderful documentary about the development and deployment and successful launch and et cetera of the James Webb Telescope, right? And you can see this if you have a subscription to Netflix. The film is called Cosmic Time Machine. And in the show notes, I have linked to this, but Joe, it's absolutely wonderful. I, honest to God, teared up a couple of times. It was so moving and so fascinating, and a great tribute to human tenacity. Something like 30 years in the development. I had no idea. 30 years. When uphill battles, sometimes Congress was about to pull the plug on the funding for this thing, and they overcame all these obstacles on and on and on and on. And and in the documentary, you'll learn about 344 points of failure, which means there were 344 things that could go wrong. If any one of those 344 things went wrong, mission failure.
Yeah.
These men and women pulled off an astonishing accomplishment where every one of those points, or the overwhelming majority, there's still, I guess, some outstanding points that could in the future go wrong. But anyway, I digress. Go and see the movie. You'll be blown away.
Definitely check that out.
The other honorable mention is scientists invent new double-sided solar panel that generates 20% more electricity. Really interesting, from a wonderful outfit called the Renewable Energy Institute. Again, we're not going to read this story. Go and check it out. We've got the links, the images, and so forth. So if nothing else, Ben and I hope, have left you feeling encouraged about the future of humans. If we can stop being stupid and have wars and hate each other, if we can get over that, hold hands as scientists and technologists, turn the world over to them, we make it.
I'm definitely going to ruffle a few feathers here and say that, yes, we should have peace. But I will say, Ralph, humans are multifaceted in that we can do both. And I'm not saying we should do both. I'm saying that even though all the bad stuff, all the news, the headlines, the what have you, ladies and gentlemen, don't worry. There are people out there who have dedicated everything to, new solar panel research, that you can find in the show notes, to, new space telescopes, new whatever, we're up to 8 billion, 8 billion of us, Ralph. There's a lot of cool stuff happening every single week. And I think you do a great job of highlighting that for everyone. So, ladies and gentlemen, again, if you want to find out more, ComputerAmerica.com, all the show notes, and of course, Ralph's segment there. He'll be back every Friday to tell us news stories. And until next time, Ralph, everyone, have a great day, have a great week, do something fun. See you next time. Bye, everyone.